Short introduction, who am I? I'm a self-employed engineer who is currently doing IT infrastructure like storage and compute stuff, HPC and security. I work primarily for biology institutes of the Austrian Academy of Sciences. I used to do web mail operations, database operations, worked a lot in data centers, did front and backend development, security auditing. Used to do booths for FreeBSD and OpenBSD in Austria and so forth. Okay. I want to do a short raise of hands. Who of you is developing open source software? Okay. Who of you already knows about environment modules? Okay. Good, it's not everybody, so that's good. I want to talk a lot to open source developers that are not aware of modules, because I think most people that come from HPC sites already know them. Okay. Environment modules were first introduced in 1991 by John Polanyi at Lisa 5. They're a concept that were originally used before Linux. I think he did that on Solaris or something like that. Environment modules are in use ever since in high-performance computing and scientific computing, where they're the main tool to abstract the environment because of ease of administration and ease of use, which you will see very soon. But most people there just refer to as modules. So if you talk to people from HPC sites and mention modules, they're probably going to know what they're talking about. They were originally intended to enable multi-user environments that have different versions of the same software running at the same time without any complications. Traditionally, most HPC environments, which I work for today, do not use system packages. Some do, but not all do. This is due to them having to compile with special compilers like intercompilers, special toolchains, math libraries, optimization of interconnect specifics like InfiniBound or Ethernet. And often scientific software is not to be found in the repositories of whatever distro you're using, because some is crap and some is not used outside of the scientific community. It's somewhat like Gentoo or Arch, if you're familiar with that. So administrators have to do a lot of stuff and a lot of compiling to do for users in the end. But it's a lot more difficult for administrators, let's say, than using Gentoo or Arch, because it's compiling the stuff is like it's a nightmare most of the time, because scientific software is often not written to be used by anybody else than the guy who originally wrote it. So a system to manage multiple versions of the same software with different toolchains is needed to maintain the stuff, and for users to easily use the system and the software that comes with the system. So what environment modules basically do, they have module files that dynamically set the environment for a specific software or software version. They may load or unload other software or other toolchains and module files depending on dependencies of the modules. Examples include path, manpath, LD library path, LD preload, and stuff like that. You probably know from developing software. So, an example from environment modules. This is an nmod specific. I'll come to that later. There are different versions of modules available today, but this is an example of how to load Git in a standard installation bar. So you see LD library path, manpath, and a config with another Git version. If the system Git is already loaded, you need to undo it and stuff. So implementations, of course. It was a good idea, but there are like 5 or 6 different versions out there now. Modules were originally written in C with the module files in TCL. So people didn't like TCL very much, so they did a lot of other implementations. Classical modes by Polanyi, as I mentioned before, is arguably still the most prevalent version that is in use at HPC sites today. Kent Mann of University of Minnesota did a rewrite of the whole thing from C in TCL, so like, let's do this whole stuff in TCL instead. There is an implementation in QC instead of TCL, and there's nowadays an implementation in Lua, which I think is the best one. I'll come to that later. Similar systems include SoftEnv and .kit. These are systems, SoftEnv is written in C shell and .kit is compatible with different scripting languages. These are very specific to the sites like Argonne National Lab and Lawrence Livermore National Lab. can share different scripts that people use, like in large model. I think they have site-specific stuff for blue GPU computers and stuff like that. I'll talk about LMOD because it's the most awesome of the environment model systems and the most well maintained. So, yeah. It's actively maintained by one of the most awesome maintainers I've ever seen. Like really, you write him a bug report and 2 hours later it's like, oh, I fixed it already. It's an active community. The mailing list is very active, but people don't report many bugs. They used to. It has cool new features instead of the old module system, like automatic swapping of module files, conflict detection. If you load, for example, 2 compilers that conflict with each other, it will spit out an error. Loading of modules with at least between and latest with regard to software version means like you use version 2.0 or 2.5 of a version that said I need between this and that version to be compatible with whatever stuff I want to use. And it's working. It also has like a spider thing. So you type module spider and it will print out any keyword that you put in. It also has caching, which makes it much faster if you search for stuff. It also has hooks. So, for example, every time you load a module, you could do a Lua function call. For example, to do statistics stuff, how many people are using which software version, or whatever you like. It has a TCL to Lua wrappers, or if you use legacy TCL modules, you can easily convert into Lua modules. It has a shell and environment wrapper, which basically you print out the environment and it just wraps the thing to a Lua module. It also has specific stuff for GPU and C and Pi computing, but I won't go into them. So examples. Module away, this is an example of our slide. It's a very small subset of the stuff. If you do module away, then you see all the different versions of the stuff you have in use, or you can use. If you module load, this is an example with Python, system Python, then I did a module load with a new Python version compiled with an Intel toolchain, and so I have instantly the new version of Python, which won't conflict with the system version. Module swap, for example, swap the Intel compiled Python with a GNU toolchain, and it nicely prints out which stuff you need to switch. Of course, there's setlib and other stuff in there, which is almost everywhere. Module spider, this is the thing we talked before. It's like you give it module spider setup tools, and it gives you everything that's there, like different versions of setup tools, different compilers. It is applicable. Module list basically tells you the current environment, which models were loaded, which models. Some of them are dependencies of other stuff I've loaded. And module display will just display the contents of a module you have in your environment or you may load. So this is a module for GCC 4.7.2. This is site-specific stuff, so the paths you see there is like from our side, but maybe any other path. There are a lot of other things to talk about, but so I want to talk about modules for free and open source developers because I don't think it's very much in use in open source development except for HPC. They could be a reasonable replacement for the vast number of language-specific environment abstraction tools like the stuff I put in my title, RVM, Virtual and Python Brew and so forth. I'm not sure why people don't use it outside of the scientific community, but I hope that people will go on to use it. I'll demonstrate with 2 examples. Let's do another raise of hands. Who is using RVM here? Anybody? Okay, it's the Ruby Environment Version Manager. It's 20,000 lines of shellcode. Last time I checked, it's being rewritten in Ruby. It basically installs and manages multiple versions of Ruby. Also does a couple of other cool things like jam sets and stuff like that. They recently did a fundraiser for 50,000 euros to do the rewrite in Ruby. They actually have corporate sponsoring from different cloud vendors that rely on this stuff because their environment is so crappy that they need it. And I write Ruby code, and I'm sorry to say it's a piece of shit. It's bloated. I won't ever use it again because it fucked up my environment on different production and different development machines. And web developers love it. So what you do is basically install Ruby 2. It downloads the source code and installs it. You can do an RVM list, RVM use Ruby 2, RVM use Ruby 1.9.2 and set it as default. And as a show, sounds familiar, right? You can do it with modules as well. So I didn't ever use Ruby 2 and use the system Ruby, and just wanted to see how many lines of code it executed. So it executes about 6,500 lines of bash code to switch the Ruby version. There's the saying, always code as if the person who ends up maintaining your code is a violent psychopath, who knows where you live. So it actually fucks with CD. If you do it set -x and just switch to any folder, regardless if there's Ruby code in it or not, it has about 170 lines of bash code that it executes for every CD you do. So maybe not the best benchmark, but you do an RVM implode and it's like instant, and without it it's like you can measure it, but of course shell is very fast now. But if you're going to use anything like that, please use RVM or consider using RVM. It's not that bad as RVM in my opinion. So I'm going to switch to something else. I forgot something. You can just simply deinstall with RVM implode because it's just leaving stuff in your environment, which is perfect, right? So another example is VisualEnv, which is far better. Most people know it, I use it as well, but it's basically the same story. You create a little environment which is a sandbox for Python stuff. People tend to use it a lot, and if you ever use like web projects and stuff like that, you come across pizza projects, you have like requirements, TXT files with like 400 or 500 different dependencies in there, and that's just a bad development practice in my opinion. Inactivate is actually a lot cleaner, like 15 lines of bash code, if you have ever looked into it, in comparison to RVM, like 6,500 lines of bash code. It's a good tool, but you probably can do a lot of stuff also with modules. There's this nice blog article on why pip and VisualEnv suck for a multi-platform developer, and Python is like developing on Windows and on Linux and on Solaris, I think. And he did like this rant about the whole stuff, and like one of the takeaways was it installs stuff like pip and easy install to your local environment, which is a bad development practice in my opinion. Also, if you're installing stuff and upgrading your projects from GitHub or something like that, it's really a mess. So if you use a web project, your HTTPS team needs to switch to the virtual environment, load this stuff to get things working. So as a comparison, handling IPython with modules is pretty easy. This is a module display of IPython which we have in our environment. It just does an ID library path, num path, Python path. This is the entire module. So you do a module IPython, and then IPython is working is exactly the version I wrote it. That's it. So what if you tell you that things could be a lot easier if you use modules? You can save time and effort maintaining the stuff. Have reproducibility, which is really a big thing, especially for scientists. Some versions they use in scientific software, the output format of some files they use for publishing papers is like a different format than the previous stuff they used. And they just publish this stuff and use different versions of the same software and get like results that I won't publish in the paper, but they do. So I think it's important to have something that is reproducible for results. And I think you can have a lot more time and fun and concentrate on what is important, and that's developing good software. So some people will say modules doesn't install software like RVM does. So back in the 70s there was like Ken Thompson who had this idea to write programs to do one thing and one thing good. And I think modules does exactly that stuff. It manages your environment. So if you have stuff that needs linking to different folders or stuff like that, it won't do that. But it will set your environment. It works with like 99% of the software we use. So like system software, scientific software, graphic stuff, whatever. You want to talk about installing software in the right way? There's a lot of different ways to do it. You can use system packages. You can use source distributions, and they're all compatible with environment modules. You just have to arrange the paths in the right way, and then you can simply load the stuff. For an excellent approach to scientific and HPC packages, talk to the EasyBuild guys. I think the next talk is from there. They have a really good framework that does not only compile the software, it does optimized builds, and different tool chains for different environments, different compilers, but also they produce module files that you can use right away. So what you saw in the beginning, like the stuff that I showed about module load, module await, and all this stuff, this was all generated with using EasyBuild. Like EasyBuild robot and do all the things, and it just works. Okay, thanks. That's it. Any questions?
I gather that if you activate another Python version, React modules, and then run fit the Python installer, it will install them inside the module.
It depends. Yeah. What we do is like we install stuff that uses pip with EasyBuild, so you have packages for that, but you can use system packages and just link to the stuff. It depends on what you want to do. But models aren't a sandbox environment, right? It just modifies your environment variables.
Yes, if the path is modified and well, virtual env replicates all the includes lib and bin, so obviously that works, and models probably is a little bit lightweight, so I don't know if it is a drop-in replacement of that use case.
No, it probably isn't, but what we do is we build stuff with EasyBuild as models, so if you have like different tips, stuff and stuff like that, we just load that with EasyBuild and compile it and load it afterwards as a module.
Basically all the module does is it like replaces the Python. It gives you a different Python executable and set the Python not differently.
Okay. What about persistence? Like when I have the module and I want it to be always used, so is there some machine runs?
You can do that. Like this is one of the features of Lmod, that you have like persistent stuff or stuff that is loaded all the time when your environment starts. This is very new. This was one of
my shell like RVM because
no. What we do, and that's optional, is to load from etc profile D. So we have a scripted set of our whole cluster environment, but all like that. But you may have noticed like PS1 is changed and stuff like that.
okay.
And we do that. So that also loads modules. Lmod in that.
And is the package some package manager?
We use EasyBuild for that.
But
just wait for
like can you package your module with RPM or that?
Your code, yes.
So one more thing that has been covered. The cool thing about the environment modules is it's shell agnostic, so it doesn't care if it's Z shell or bash.
Yeah. So you mentioned dependencies between modules. At that point, modules become environment packages almost. How do you solve the dependency problem? Because it's like a satisfiability problem.
Somewhat. So you have families of modules. Some families can interact with ours, like compilers, and then you have modules. You may have noticed like conflict and have a package in there. So if it conflicts with another package, say no, you can't use it, or you need to swap it with another package. Simple as that.
Okay, so you maintain all the individual conflicts yourself. Can you satisfy?
If you would do it by hand, yes, you need to. But we do it auto-generated. Like none of the models we saw are like written by hand. They're all compiled with EasyBuild.
Ah, okay.
So I think I have this slot because they are going to talk about EasyBuild, and like this is of course a question that pops up. Right?
All right. Let's close it here. Thank you, Aaron.